So welcome everyone. This is lecture number 8 and we are going to start and complete polarization in today's class. Now, anyone heard about the term polarization before? Yes or no? Polarized cameras, Aviram has heard. What do you mean by polarization then, Aviram? Tell me. You heard the term polarization? What do you mean by the term polarization? Okay. Now, remember, let us start with the term polarization. This simple things. You just have to remember 2 or 3 things in the entire chapter and you are good to go, because this chapter actually has literally nothing that can trouble us. I just had this problem. Give me a couple of minutes. I think I've closed that question wala sheet. I just need to open it. Where it is here. Okay. Yes. So what do you mean by the term polarization? Okay, now what is going to happen is we are jumping into the last portion of the wave nature of light, and this is one of those things that tells us that light is definitely a wave. Interference tells us light is a wave. Polarization tells us that light is a wave. Now, what do you mean by the term polarization? Before going on the term polarization, let us first understand what do you mean by unpolarized light. Anyone knows what do you mean by unpolarized light? Unpolarized light. Now we'll just go through simple facts about light. You must know that light is a electromagnetic wave. Yes or no? Light is an electromagnetic wave. Now we will have this topic of electromagnetic wave, which I will cover very soon. Light is an electromagnetic wave. What it means is it consists of both electric field as well as magnetic field. Both electric field as well as magnetic field. Now these electric field as well as magnetic field are always perpendicular to each other. That is the second thing that you must remember, because these all points can come as questions in your exam. So this electric field E, I hope you understand the meaning of electric field, and this magnetic field B. You must have heard about electric and magnetic field. Yes or no? Electric field and magnetic field. Now this electric field and magnetic field both are perpendicular to each other, and it is perpendicular to the direction of propagation of wave. So all these three directions are perpendicular to each other. If one is along x-axis, the second one will be along y-axis, and the third one will be along z-axis. They are all perpendicular to each other. Light as an electromagnetic wave consists of electric and magnetic fields. These electric and magnetic fields, as well as the direction of propagation, these three are perpendicular to each other. Now, for the case of this polarization or unpolarized or polarized light, what we are going to assume is this magnetic field. If we talk about the strength of this magnetic field, this is very small compared to the electric field. We can actually neglect this magnetic field. If you compare it with the electric field, the magnetic field strength is very less compared to the electric field. So for this particular chapter, what we are going to do, we are going to neglect this magnetic field completely, and we are going to imagine that light only consists of electric field. Do we understand this? So yes, we will assume that light only consists of electric field oscillation. So there is only one electric field and there is one direction of propagation of wave. Now, what do you mean by unpolarized light? Now, light which is having the electric field oscillations, light having this electric field oscillations in all directions, in the plane which is perpendicular to the direction of propagation of wave this type of light is known as an unpolarized light. Now, writing it may look very difficult, but understanding it is not very difficult. Let us say, for an example, this is the direction of propagation of light. It is moving along x-axis. Now, if it is moving along x-axis, this plane is the YZ plane. So basically, this electric field can be in any direction in this YZ plane because this YZ plane is perpendicular to your x-axis. Do we understand this?
Yes, sir.
So if light is propagating on x-axis, your electric field can be in any direction on this YZ plane. Such type of light is known as an unpolarized light. I hope you are writing it. I will also show it in with a diagram. So I'll show you this diagram, and that will probably make more sense than in writing the entire definition. Remember, no one is going to ask you the definition. If you understand it, that is all that we want. So this is what I mean by plane perpendicular. This, as you can see, my dear friends, oops, I cannot draw a straight line. This, as you can see, my dear friends, is your x-axis. Oops, again, not a straight line. What's happening? Can't draw a straight line or what? This is your x-axis. As you can see, light is propagating. When I say propagating, light is moving, simple. But the word is used that is propagating. Then, as you can see, bacha, this is your YZ plane. And these are all the random directions of electric field in the YZ plane. If you look at the YZ plane from the front, you will see electric field like this. Such type of light which has electric field oscillations in all the direction in the plane which is perpendicular to the direction of propagation is known as unpolarized light. Do you have any problem, bacha, in the class? Are you able to see me? Are you able to hear me? You understand this? No?
Yes, sir.
Okay, bacha, please note this down. The only thing you have to understand in this is 2 or 3 diagrams, and that's it. And very simple diagrams. And one question for your NEET is definitely going to come from polarization. One question is going to come from diffraction, and one question probably will come from wave optics. So 3 questions are there. Simple things. I'll give you 2 minutes to note this down. Note it down. Please let me know once you're done, bacha.
Completed, sir.
Okay. This is unpolarized light. Now, if this is unpolarized light, beta, What would you mean by polarized light? Now, before understanding this unpolarized, let me show you one more diagram which makes the point pretty much clear. So I'll show you one more diagram. You can draw this diagram as well. This is for your understanding of how light is moving and how it is unpolarized. As you can see, look at the things that I'm drawing here. This is the direction. This is x-axis. This is the direction of light propagation. Light is moving along this axis. This is your y-axis. So electric field is oscillating like this, dung 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 dung. And this dot that you see, this dot is your z-axis actually. Z-axis is given by dots. So this is your z-axis, and as you can see, this plane, this unpolarized light is having oscillation in the YZ plane, and it is moving along the x-axis. So this is your unpolarized light. Now, if this is your unpolarized light, then bacha, how will your polarized light look like? You can tell me, how will your polarized light look like? This unpolarized light has oscillation in the plane, all directions in the plane. What will a polarized light look like? Yes, any idea? How will a polarized light look like? Have you drawn this? Yes, Aviram, that is exactly what we are going to discuss. It is going to have oscillations in just one direction or one plane. So let us first everyone write this, and then we will move. Everyone has noted this down?
Done, sir.
Boys in the other class? They are noting it down, so let me give them time.
Completed, sir.
Okay. Then how would your polarized light look like? So write the heading polarized light. Polarized light. How will a polarized light look like? So light having oscillations having oscillations in one plane is called polarized light, or sometime it is known as plane polarized light. It has oscillation only in one specific direction. The plane in which oscillation occur that plane is known as the plane of oscillation. So plane of oscillation is the plane in which oscillation occur. Plane that is perpendicular to the plane of oscillation. That plane is known as the plane of polarization. So there are two planes that you must remember. Plane of oscillation and plane of polarization. Note this down. Now, how do you polarize a light? You can also note it down. Light is polarized by passing it through a device or a crystal, which is known as a polaroid. Polaroid. You must have heard about Polaroid cameras. Polaroids. I'll give you 2 minutes to note this down.
Done, sir.
Everyone?
Sir, 1 minute.
Shall we move ahead, bacha?
Yes, sir.
Okay. Now, as you have seen that the device that can create a plane polarized light is known as a polaroid. Now let us see how that device make a unpolarized light polarized one. So the next heading that you are going to write is a polarizer or a polaroid. Polaroid. What is a polaroid? It's a device to produce plane polarized light. And how does it produce a plane polarized light? Well, the example would be like this. It looks like this. It is a crystal that looks like this. On the left hand side, what you see is a plane, is an unpolarized light. It's an unpolarized light. The light is moving in this direction, x-axis. You can see vibration on y-axis. You can also see vibration on the z-axis. So electric field is oscillating on y and z plane. It is also on y-axis. It is also on z-axis. Then you have this device which is known as polaroid. After passing through the polaroid, what happens is it only allows transmission along one axis. This axis, as you can see here, is known as a transmission axis. Every polaroid has this transmission axis. So it only allows those vibrations which are parallel to it to pass. After passing, what happens? You can see this is the light which is going, and it only has vibration along y-axis. The vibration along z-axis have all been absorbed, and therefore this light becomes a plain polarized light. What you got to remember is polarites only allow oscillations parallel to transmission axis to pass. All of the other oscillations are absorbed. That is the first thing that you must note. The next thing that you must note is if the intensity of light here is II, I capital I standing for intensity, small I standing for incident light. If the intensity on the left hand side, the unpolarized light is II, intensity after polarization becomes II by 2. Why it becomes by 2? You can just understand it in this way. Only one axis is passing, the other axis is absorbed. So the intensity becomes half. So that is the next point that you must remember. Intensity of polarized light is half of unpolarized light. Do we understand this? I'll give you 2 minutes to note everything down. Note them down. After that, we only have 2 things to note and we are done.
Done, sir.
Other class, we are done, bacha?
1 minute, sir.
Okay. Completed? Okay.
Yes, sir.
Now, as soon as we talk about a Polaroid or a polarizer, we must also talk about the next thing which is known as analyzer. Now, what is this polarizer and what is this analyzer? Is nothing to be worried about. The best way to understand this polarizer analyzer is by this diagram. This chapter is all about simple diagrams. If you remember these simple diagrams, we just understand everything in this topic. So what is an analyzer? Let us start from the very first thing. On the left hand side, I have unpolarized light. As you can see, this is the direction of propagation. This is y-axis ka oscillation, and this is z-axis ka oscillation. Unpolarized light, ordinary light. The intensity here is II. We put a polarizer. As you can see, this is the transmission axis of the polarizer. After polarizer, the light passes. This is the x-axis. This is the y-axis. It only allows transmission along y-axis. Z wala components are cancelled. This becomes your polarized light. Anyone following me? Yes or no? The intensity of this light, which is on this side, becomes II by 2. Yes or no? Now, if I place one more polarizer after this first one, so the first one will be known as polarizer, and the second one is known as the analyzer. So analyzer, basically what it does, it analyzes the light which has been polarized by the polarizer. Now here what you see is the transmission axis of the polarizer and the transmission axis of the analyzer are both parallel. So it allows all the light to pass through. So the light which is passing through this one will have the same intensity as the light which is falling on this one. That is the point that you have to note. If the transmission axis of the polarizer and the analyzer are parallel to each other, question has come on this diagram. Entire light passes through the analyzer. Do we understand this? It's very simple. There is no doubt here. If you put two polarizers, the first polarizer is known as the polarizer. Sorry, I should say, if you put two polarides, the first polaride is known as the polarizer, which polarizes. The second polaride is known as the analyzer. I'll give you 2 minutes to note this down. Completed both of you? Both classes?
Yes, sir.
Sir,
Okay.
1 minute.
Yeah. One is saying completed, other is saying 1 minute. So you have started the same thing that your JEE counterparts do. Compete with each other. Compete with each other, but not in terms of who finishes first. Compete with each other in terms of who understands first. That would be a fair competition.
Done, sir.
Then, sir, give me 1 minute, sir. Okay. Now, if we place the two polarides parallel to each other, you have entire light passing. What can be the reverse case of this? If I do it the other way around, means I change the angle from 0 to my favorite 90 degrees, then what happens? Again, let us start. This is unpolarized light. I'm writing it every time so that you understand what is an unpolarized light. So many times. This is the direction of propagation. This is y-axis and this is z-axis. You see all the three. You put the polarizer. This is ordinary light. The intensity is II. Intensity is II. Then on the this hand side, I get polarized light. You see, this is the direction of propagation. You only have oscillations on the y-axis. This is your intensity becomes half. Yes or no?
Yes, sir.
Now what do I do? This is the polarizer. Now I put the analyzer at an angle of 90 degrees. You have no light here. The intensity becomes 0. Nothing comes. So basically what you have to understand that is perpendicular. If you put the analyzer perpendicular to the polarizer, you will get nothing on the other side. Do you understand this? Draw the diagram, note it down because the diagram has come.
Done, sir.
Completed, everyone? I'm waiting.
Completed, sir.
Okay. Let us give everyone time so that they can do the needful. Shall I move ahead now?
Yes, sir.
Now the question comes, if they are parallel, everything passes. If they are perpendicular, nothing passes. What will happen if the angle is not 0 or 90? And that brings us to the first of the two laws that we have to do, that is known as the Malus law. That is known as the Malus law. Here the angle is not going to be 0. Here the angle is not going to be 90. Here the angle is going to be theta. And instead of giving you the definition, I will show you the diagram because the diagram is important and nothing else. I'll show you a diagram and then I will try to make you understand what is this Malus law. Again, I start. This is unpolarized light. The intensity here is II. I put a polarizer. I hope you can see it. This is unpolarized light, II. I put a polarizer. I get a plane polarized light. The intensity becomes II by 2. Now I put a analyzer and the angle, the transmission axis. See, these are parallel transmission axis. This is perpendicular. So now the transmission axis is like this, 3 dimension. The angle in the between the transmission axis is theta. Do you see this? So now when I have the intensity on this side, the third side, the intensity on this side is II by 2 cos square theta. And this statement, my dear friends, is known as Malus law. The intensity after the analyzer is cos square times intensity after the polarizer. Do we understand this? Now, if you put the angle of theta as 0, you will get same intensity. If you put the angle theta as 90, you will get 0 intensity. At any other angle, you will get the intensity. Do we understand this? Yes or no? No, yes. This law is known as Malus law. Malus law says that the intensity of the polarized light after the analyzer varies as the square of the cosine of the angle between the analyzer and the polarizer. I'll give you 2 minutes. Do it fast.
Done, sir.
What about the other class, sir? Do it fast.
Sir.
Done, sir, everyone? Then the last thing that you have to learn, or you only have to learn 2 laws here. The first law was known as the Malus law. The second law is known as the Brewster's law. What is this Brewster's law? Remember simple things and you would do good. Brewster's law. Now again, understanding this law would be easiest in terms of the diagram. So I again shall show you a diagram and then you'll have to remember simple things and we are done with polarization. This is the diagram that we are concerned here. The diagram comes on your screen now. Now what is this? What is happening here? Okay. Now you must first understand that we have done reflection and refraction. Whenever light falls on a surface, it is not 100% reflection and 100% refraction. Some part is reflected and some part is refracted. We understand this? Depending on the angle of incidence, the angle of reflection and the angle of refraction changes. At one particular angle of incidence, which is known as theta p, at one particular angle of incidence, which is known as theta p, which is known as the Brewster angle, when the angle of incidence is your Brewster angle, then what happens? Your reflected light is completely polarized. You have completely polarized reflected light. Completely polarized reflected light. This angle of incidence at which your reflected light is completely polarized is known as your Brewster angle. Do we understand this? One more thing happens at this Brewster angle, that your reflected light and your refracted light, they are at 90 degrees. So one more thing happens at this Brewster angle, your reflected light and the refracted light are perpendicular to each other. Are perpendicular to each other. This is all about Brewster angle. So this angle is 90 degrees. This angle is theta p. Brewster angle. Angle of reflection is also same as angle of incidence, theta p. One is 90, So you can write this angle will be 90 minus theta p. So your angle of refraction actually becomes 90 minus theta p. You can also write this as a note if you want to. The angle of refraction R becomes 90 minus theta p. So if a question comes, just have to remember these things. If you can remember these two things, Brewster angle and your Malus law, you are good to go. I'll give you 2 minutes to note it down. Note it down fast so that we can do 1 or 2 problems.
Done, sir.
Shall we move on ahead in life? Remember, the only thing that they are going to do in this question is to write the question in a form that confuses you. So this is that form. I hope you can understand the meaning of the question and get the answer. This is question number 1. And this question has come many times in many exams with the same value even. When light of a certain wavelength is incident on a plane surface at a glancing angle, glancing angle? No incident angle, glancing angle. Language. The reflected light is found to be completely polarized. Determine the refractive index of the material and the angle of refraction. As soon as I heard about refractive index, I forgot to give you a formula. So please note that formula. I forgot it completely. And the formula is mu. The refractive index of this is tan of theta p. Mu, the refractive index of the material, is tan of theta p. I just completely forgot to give you this formula. So note this formula also, and then once you have noted the formula, you can move on to the question. I hope everyone has noted the formula. Then you can move on to this question and give me the answer for this question. You have 2 minutes to do this.
Sir,
Bacha,
sir, mu equals to root 3.
mu is equal to root 3. That is correct. You must understand what do you mean by the glancing angle. If you understand the meaning of glancing angle, you understand everything. See, if this is the surface and this is the perpendicular, and if I say that this is your incident light, glancing angle 30 degree means we are talking about this angle as 30 degrees. So your angle of incidence becomes your 60 degrees. And at this angle of incidence, what we are saying is the reflected light is completely plane polarized. That means this has to be the Brewster angle. Yes or no? This is the Brewster angle. As soon as we understand that this is the Brewster angle, I can write tan of Brewster angle theta p is your mu. Tan of 60 is root 3. So mu becomes equal to root 3. Then they're asking you find out the value of the angle of refraction. I've already told you how to find out the angle of refraction. Angle of incidence is 60 degrees. 90 minus 60 would be the angle of refraction. So it will be 30 degrees. Yes or no, bacha?
Yes, sir.
So that is what you remember to solve any problem. Do we understand this? Yes or no?
Yes, sir.
Before going, I must also solve one problem on that Polaroid. So this is the problem on Polaroid, a simple one. Everyone has noted this down? You can see the problems are so simple in this polarization. If they come, you can do them in 1 minute, less than a minute, 10 seconds, 20 seconds. And here is the problem on polarides. Same problem comes many times in many ways. I'll give you 2 minutes. Two polarides are oriented with their plane perpendicular to the incident light and transmission axis, making an angle of 30 degrees. So what you have to understand is transmission axis is making an angle of 30 degrees with each other. What fraction of light which is unpolarized? So basically you have one polarite which is polarizer, you have one more polarite which is analyzer. Unpolarized light is falling on the polarizer. So many diagrams I've shown you. Unpolarized light is falling on the polarizer. Light is coming out of the analyzer. What fraction of light from the analyzer is coming out? That is what you have to find out. The angle between the polarizers is 30 degrees. The only thing you have to remember is 30 degrees. And if you want a hint to how to solve the problem, the hint is right here in this dabba. I is the intensity of light which is passing through. II is the intensity of light which is falling. You just have to remember this one formula, my dear friends, and you can solve any question, including this one. So how are you going to solve this question?
Sir,
Yes,
3 by 8.
3 by 8, that is correct. I will be equal to, I is the intensity after the analyzer, that will be equal to II by 2 into cos square theta is 30 degrees. So I divided by II, which is the fraction of light which is passing, is half. Cos of 30 is root 3 by 2. Root 3 by 2 square. So I divided by II will be 3 by 8. You can expect a similar question. They might just change the angle. From 30, they can make it to 45 or 60 or 37. Doesn't matter, whatever they do. The question has to be solved in this particular way. Do we understand this? Only two formulas you have to remember. Intensity after analyzer is II by 2 cos square theta, and mu is equal to tan IP. The reflected and the refracted ray are 90 degrees, and that's it. That's all about polarization that you have to remember. We are done with the wave nature of light. In the next class, that is tomorrow, we will start with the particle nature of light. Particle. Now light will become a particle. And we will venture into the easiest topic of all of physics, modern physics. Take care. I'll meet you tomorrow. Have a nice day. God bless you all.